So tomorrow, and we'll be doing a lab, we'll talk about some of those details. I'd first like to just kind of set up the scenario with you guys. We're going to set up the situation. Now, the situation is going to be the distance between two non-accessible points. The distance between two non-accessible points, I had some students ask, what do you mean by that? That means that there's 2 points, like across the valley or across the ravine, and you can see them, but you can't touch them, you can't measure them, you can't be there. They're not accessible, but they are seeable, you can see them. So to help you kind of visualize this a little bit, 2 points of non-passable area. And there we go. I'm trying to find the distance AB. Now, just so you get the idea, you're gonna be over here, and some days maybe you feel like this fellow, you can see like his color arrangement is kind of neat, or maybe sometimes you feel a little more like this. Okay, but if you try to go into the non-passable area, this is kind of rated PG-13, so you have to the alligator ate a lollipop, in case anybody's confused. I'm not sure what else happened, but if you go into the non-passable area, you may be attacked by an alligator. So we don't want to do that. But the good news is we have some math that we can use. That is some trigonometry. Let's set it up a little bit more. Basically, we're going to make a diagram. Like I said, you're going to probably want to jot this down. Not only for tomorrow, but you will see a similar diagram someday on a test or quiz, and it might be something that you feel like you want to look back at. All right. Not going to draw any alligators, but we will locate points A and B in some kind of non-passable area. Now, I bet you won't be too shocked to say or see me say or hear me say that we need a point C. We need a point C on this side so that we can have the old triangle. Okay, you knew that side AB was going to become part of a triangle, but let's let it look like this. Okay, now this is good stuff because side AB is obviously part of the triangle. And we can measure something, right? We can measure angle C. You know, like you can measure it with a transit. And you'll do that. But the problem is that, at least with what we have sketched right here, that's all you can do, right? We kind of be staring at this angle for the rest of the lab, and we would have trouble getting this side. Now, what if you also knew this side and this side? Well, now you'd be in business because now you would have a side angle side. Okay, so I kind of want you to imagine that you do have those sides, but you won't be able to measure them. You know, you can't access them. It would mean you have to throw a tape measure across or something. And again, that's not the idea. Let's figure out how we can get these two sides using some more trigonometry. And this is kind of the part where, if you don't mind, I'm going to show you. I always thought it'd be fun if students could kind of figure this out, but it probably would take like, the whole day, which wouldn't be anything wrong with it if you don't have that time. So, how about if we locate another point out here, beforehand you sketch it, just listen to one more thing, that makes a right angle right here. I didn't really sketch it looking like a right angle, but imagine that you made a right angle with this point D. Okay, well, now we got a little bit more that we can measure. Okay, just by making this point D right here, we've got a little bit more that we can measure. We can measure this distance. That'd be pretty easy with a tape measure. But you can also measure this angle. And I'm sure that you see the right triangle, which is part of all of these measurements. Okay, and that certainly is the idea, because remember that side you wanted to find? Side AC, I guess we could call it. Okay, it's now part of that right triangle. And in fact, it would be able to be determined. Point D, pretty nice, okay? Making a right angle. We're actually gonna be able to do the same thing over here. Now again, before you draw something, just take a look, because I wanna show you something else here. Do you realize that point E, we wanna be careful that we don't say could be anywhere, but there are some options for point E and point D, because all we gotta do is make sure that it's somewhere on this line that makes a right angle. Okay, so the location of point E will be kind of interesting during the lab, because again, you could place it, careful how we say it, but you could place it anywhere as long as you get a right angle. Okay, as long as you get a right angle here. Okay, and that you will do. That you will do, so you can measure, and measure. Now our sketch has been enhanced. We've got a couple right triangles. And what I'd like you for you to do is have a chance to kind of practice the pencil and paper math. Okay, now we're gonna go outside tomorrow and we'll still talk about some of that, but it's helpful that you know how to do this on paper. Basically, using law of sines, law of cosines, or maybe SOHCAHTOA to see if you can get yourself to that final answer. I made up some numbers here. Put them in your sketch. And see if you can find the AB. See if you can find the AB. Now there are different ways to go about this. Be careful that you don't just kind of jump in and find every single number that you can find. There's really only some numbers that you need to find so that you can get to AB.